Alright, on today's lesson we're still going to be completing the square. Today though we are going to have imaginary answers. The thing you need to know is that whenever you see the square root of a negative, you're going to use the imaginary unit I. So that's I equals the square root of negative 1. So when I'm taking a look at number 1, the first thing I'm going to do is represent the negative that's inside the square root that I cannot do as the square root of negative 1 times 16. So now I can rewrite the square root of negative 1 as I. And I'd still have the square root of 16 multiplying it. This is an imaginary, complex answer that's not real. Now, the square root of 16 is 4, so 4i would be my simplified answer for number 1's problem. Alright, number 2, same thing. Well, let's first of all rewrite that square root of negative 1 times 18. Then I can actually represent the square root of negative 1 with I, so I times the square root of 18. Now, 18 is a little different than 16. This is irrational number since I cannot take its square root, but I can divide it by a perfect square, which is 9. 9 goes into 18 twice. And then I'll square root the 9, which is 3. So 3i times the square root of 2. So now I'm going to walk through two examples where you're going to see imaginary complex roots. So like on this first one, since there is no bx term, I'm actually going to use the square root method, where my first step would be to subtract 32 from both sides. So 4x squared would equal negative 32. Then what I'll do is divide by 4 on both sides. So x squared would equal negative 8. And now I will plus or minus the square root. Now you can never square root a negative. That was the whole purpose of representing that with an I. So first thing I'm going to do is change it to negative 1 times 8. And now I can write that as x equals positive or negative I times the square root of 8. Not quite done on this problem though, because what I still have to do is I have to simplify the square root of 8 if possible. Now in this case it is, because 4 is a perfect square that goes into it twice. So I'm going to rewrite the 8 as 4 times 2. And now time for my final answer. X equals plus or minus. The square root of 4 is 2, so I'll write that outside with the I that was already there, times the square root of 2, which I could not take the square root of. There's my two answers. 2i root 2 and negative 2i root 2. Alright, on this last example for today's lesson, I'm actually going to use completing the square because I do have a bx term. So I'm going to start off by actually subtracting the 15 over to the right hand side. And I'll have x squared plus 6x, leave a little space for completing the square, equals negative 15. What I'll now do is use my formula for completing the square, which is b divided by 2 squared. Here, the b value is 6. So 6 divided by 2 squared, which is 3 squared, and that will be positive 9. That's what I will add to both sides of the equation now. Now I'm ready to factor this left side. And that's going to be x plus 3 squared. And that's coming from the fact that it was 3 right before I squared it. 3 times 3 is 9. 3 plus 3 is 6. Everything's looking good here. Negative 15 plus 9 is negative 6. Now I'm ready to plus or minus the square root. So x plus 3 will equal the positive or negative square root of negative 6. Again, this is going to be an imaginary unit. So x plus 3 is equal to positive or negative I root 6. There I just skipped the step of writing it as negative 1 times 6. Just went ahead and brought the I out from the negative. And I need to now simplify the square root of 6. However, 6 has no perfect square that will divide into it. 4 won't divide into it, nor will any others that will help simplify it. So I'm going to leave it as is. This is actually simplified. My last step is to subtract the 3 from both sides to solve for x. So that x will equal negative 3 plus or minus I root 6. Alright, that does it. Take a look at the document on my website to see the assignment for this day. Thank you very much.